more reviews. So 3D printing is a form of additive manufacturing, which means that it adds material to create something rather than removing it. Like subtractive manufacturing, which is the alternative to 3D printing. And it's a more recent technology. It's only came out within the last 30 years or so when it was first started being used commercially, and it can make just about any shape that you want it to. So the procedure for my project is first I have to create an equation, then I have to calculate the volume, then I have to input that equation into a CAD program, rotate it around the axis, export it to a 3D printer, print the model, and then measure the volume again to see how close I was. So now we're going to talk about some important equations you might need to know. How to find mass. So the equation for density, which we'll be using, is P equals M over B. And P is the density in grams per cubic centimeters, M is the mass in grams, and B is the volume in cubic centimeters. And if we solve for mass, we get density times volume equals mass. And to find volume, we can use the disk method. And in this equation, the V is volume of the solid form, and then A and B are the limits in the x-axis. So when I measured the volume of the shape after I printed it, the weight was 13 grams, or it came out 13 grams, and the density was 1.25 grams per cubic centimeter. So I was able to divide the grams per cubic centimeters by what I measured for the weight, and I got about 10.4 cubic centimeters as the volume. And then using water displacement, I got the volume to be about 10.5 cubic centimeters. And so here's my equation I was using, y divided by x squared over 10 plus 0.6, and that's the equation it formed. So to calculate the volume of this, if we rotate it around the x-axis, we do the disk method. So the disk method is 2 pi, the integral from a to b of your equation squared. And so doing this, first you take the antiderivative, and then you get that, or the integral of it, then you get that. I'm not going to show you guys how to take an antiderivative. Next, you put your numbers in for the x's, and then you solve. And I got about 10.8 cubic centimeters as the volume of my object. And then now to calculate the mass, we take the density, which is about 1.25 grams per cubic centimeters, times 10.809, comes out to about 13.5 grams. Okay, so to create the shape, we actually use a CAD program called Fusion 360, which allows you to create 3D models. And we started with a 2D sketch of the paraboloid, and then I enclosed it around the x-axis, and then I rotated the sketch around the x-axis to create a 3-dimensional model. This created this. Here's my video. I would turn on the sound, but it's kind of annoying. It's the buzzing noise like that, but it's really close up and loud. So that's just that. That's just the printer printing the object. And here's an interactive animation of this method. So you can put any, I gotta go through here. If you put in an equation, you can have it rotate about you can have it put in any equation, then you can have it revolve on the x-axis, and it kind of just shows you what this method is and what it's doing. And here's some of the resources I use. These both just kind of give some explanation into the calculus of 3D printing and the disk method. And for the class problem, the function is going to be f of x equals x squared minus 4, and then the density is going to be 1.5 grams per cubic centimeter.